So let's start with the absolute basics. What are atoms, elements, mixtures and compounds? So, atoms. Atoms are made up of a nucleus, and around that nucleus you have orbiting electrons. Inside your nucleus, making up your nucleus, you've got protons and neutrons. Elements. Something is an element if it contains only one kind of atom. Mixture. Well, here you have different atoms, but this mixture can be separated by physical means. That is to say, I can filter to separate solid from liquid. I can evaporate to remove water from the solid. Physical means. A compound, here your elements are bonded chemically. So you can't separate these by filtering or by applying a magnet to remove iron or cobalt or nickel or steel from some other thing like sand, for example. So they cannot be separated by physical means. So chemical symbols then, and what they mean. We've got the periodic table, and each element in the periodic table has its own symbol. Now you can see that lithium here, for example, has a capital L and a lowercase I. And over here we have boron, carbon, nitrogen, oxygen, fluorine that are only a single capital letter. So an element begins with a capital letter. That's the symbol, begins with a capital letter. Lithium is Li, boron is B. So if I had, for example, silicon dioxide, I would have SiO2. I would know that the Si had to be a single element because I've got a capital letter and a lowercase, and the oxygen is another element because it starts with a capital letter. So you have your symbols which always begin with a capital and maybe only a capital letter, but most of them you can see have a capital letter and a lowercase letter. What do these symbols mean? Well, apart from the letters, we also have the numbers, the 7 and the 3 here. What the 7 tells us is the number of protons and neutrons in total in the nucleus, and the 3 tells us the number of protons. So let's consider lithium. We'll go back to lithium. We have 7, 3, 7 there, 3 there. That tells us the number of protons and neutrons in total, and that tells us the number of protons in the nucleus. Now, along with that, we have the idea of charges on atoms and ions. So I said you have your electrons orbiting around the outside, and you have your nucleus in here. Now for lithium, we have 3 protons, and because we have 7 in total, we have 4 neutrons in there. Each of these protons has a positive charge, +1. Atoms are neutral. They have no overall charge, which means that lithium has to have 3 negative charges to offset the 3 positive in the nucleus, and they are in the electrons orbiting around the nucleus. And what you have is the inner orbit or shell of electrons can only have 2 electrons. The next one, and as far as you're concerned for now, all of the other shells can only have 8 in total. They can have less than 8, but they can't have more. So here we have the inner shell of lithium, which of course is full because it has 3 electrons, and then you have this shell which has 1 electron in it. So atoms are neutral. But they want to have a full outer shell or orbit of electrons. So lithium has got 1 here. It wants to have a full outer shell, which means it either has to have just this shell, which has 2 electrons in it, or it has to have another 7 in this shell. Now what lithium will do, and if we go back to all our other elements in the periodic table, what lithium will do, sodium, potassium, rubidium, cesium, francium, all of these elements have all got 1 electron in the outside shell. And so they will all look to lose that electron by combining with something that will take it from them. So we have our metals. Mostly the table is metal. If we were to draw a line here, everything on this side is a non-metal. Everything over here, the majority of the table, they're metals. So these metals will combine with non-metals. They will form compounds with the non-metals. In the case of this group 1, these will lose 1 electron and they'll give it up to the non-metal they combine with. So they will form ions. So your lithium will give away an electron so it has a full shell, full outer shell. It just has those 2 electrons in the first shell. But in losing that electron, it still has the same number of protons, so it becomes a lithium ion. The ion has a positive charge. Now, if lithium was to combine with oxygen, for example, if we go back to our oxygen, our periodic table, oxygen is over here. Now that's group 1, group 2. These are our transition metals, 3, 4, 5, 6. So oxygen is group 6, which means that oxygen has got 6 electrons in its outer shell, and it wants 8. So if oxygen then was to gain 2 electrons, it would now have 8 electrons in its outer shell, which would mean oxygen would now have 2 negative charges it didn't have before. So oxygen forms an O2 minus ion. And so lithium oxide which is the compound formed when lithium reacts with oxygen to provide the full outer shells that each of them wants, would have to be neutral. Which means for every oxygen, there has to be 2 lithiums combined with it. So you would have Li2O. That would be the chemical formula for lithium oxide. Let's go back to the periodic table and just be very clear what we're talking about here. We have columns which we call the groups. Group 1 over here, group 2 in this column. Transition metals, which we don't talk about at this stage. Group 3, group 4, group 5, group 6, group 7. And then, well, you could call this group 8 or you could call it group 0. You can see helium, 2 protons, therefore 2 electrons, therefore full outer shell. Neon, 10 protons, therefore 10 electrons, 2 in the first, 8 in the second shell, full outer shell. Argon, 18, 2, 8 like neon, plus another 8, another full outer shell, and so on. If you do that for all of these, what you find is that all of these have got a full outer shell. So these have no reason to react. They are inert or noble. These are the noble gases. Noble because they stand above, aloof from everything else. They don't get involved in all the things that these elements do. They are unreactive. So you have group 8 or group 0. 8 suits all of them apart from helium, which only has 2 electrons in the outside shell. These all have 8. So group 0 suits the group rather well. So each of the groups tells you the number of electrons in the outside shell, in the atom. The rows, these are the periods, and what happens is you move across lithium, beryllium, C3, 4 protons, 5, 6, 7, 8, 9, 10 protons. Now you start a new shell. Here, remember, this was a full outer shell. So now we have a new shell beginning with 1 electron on the outside shell, and then we add another electron to the outside shell because we have another proton, and so on, 13, 14, 15, 16, 17. Now we have another full outer shell, start a new outer shell, 1 electron on the outside shell, 2, 3, 4. So every time you come down a row, that is to say, you come down a period in the table, we call the rows the periods, what you're doing is starting a new shell of electrons, having got to the end over here in group 0, where the shell is now full. If you move across, you're gradually filling the shell, you get to here, the shell is full, you start a new shell, and so on. So that's the basics of the periodic table. Like I said, you have this group in the middle here, the transition metals, which have some very interesting properties. We're not going to talk about those right now. We're just looking at the very basics of how chemistry works.